Hello and welcome to this video. My name is Pavel and today I'd like to show you how to enable AI applications on Kubernetes with NVIDIA GPUs. There are a couple components that we would mention. Gardener, it's an open source project enabling you to manage Kubernetes clusters at scale across your infrastructure of choice. We will be using Garden Linux as the default operating system recommended for Gardener. And last but not least, the NVIDIA GPU operator. It will take care of everything required to take advantage of the NVIDIA GPUs. You can read the full blog post with more details at the link in the description or just go to documentation.apero.eu/blog. Now let's dive into it. First, we are going to prepare our Kubernetes cluster. Then we are going to install the GPU operator, and then we are even going to test it with an example container. Now let's move into the Gardener dashboard. This is the place where we can manage all our infrastructure. We can see the clusters that have been created and the different Kubernetes versions. In this example, we have a project which hosts a cluster in AliCloud in Frankfurt, an Azure cluster created in Zurich, and a Google Cloud cluster hosted in Madrid. Also, there is an OpenStack installation hosted in Germany in Walldorf. Now, let's create a new cluster. We can use any of the providers available, and today we are going to use AWS as the default option, and we are going to call the cluster with the name AWS DE Frankfurt. We are going to use the region of EU Central 1, which is Frankfurt. And we are going to provide a couple of machines. First, we are going to have a standard machine of the M5 type, which does not have a GPU. We are going to use the Central 1A zone, and then we are going to add our GPU-enabled machine. We're going to use the G4 machines, and we're going to take the G4 DN extra large machine. And we can configure maintenance intervals which are acceptable for us so that Gardener knows when to manage the cluster and auto-update it for us. Gardener also has a very cool feature which enables us to hibernate our clusters when we don't need them in order to save costs. Now let's hit the create button on the bottom right. And that's it. Now our cluster is being created. We are going to have to wait for a moment until the create processing status is changed, and we can actively monitor the progress. You can see that currently the infrastructure is being reconciled, and we are going to have to wait for a moment. Okay. Now we can see that the creation has succeeded. We can continue with using our cluster. We can do that either locally from our favorite client or from the built-in terminal in the Gardener dashboard. I'm going to use the Gardener dashboard and create a pane that is split horizontally. This would make it easier for us to monitor the changes we are making to the cluster. Let's first take a look into the namespaces. Now, let's take a look into the standard installation provided by NVIDIA GPU operator. First, we need to make sure we have Helm installed, so let's just take a moment to make sure Helm is available. Then we can skip some of the instructions for the sake of time and just make sure that we have added the Helm repository for NVIDIA. This is really required if we intend to use the Helm NVIDIA chart provided for the operator. Now, we can continue with following the Garden Linux NVIDIA install repository. In here, there is a simple command that you can use to install the operator. You can just see that there is a small difference provided by us from the standard documentation by NVIDIA. there is a reference to a GPU operator values file, which contains a specific driver repository location, which you might want to use, or you might want to change to a replicated copy in case you're running in an air-gapped environment. It also enables you to configure the driver version that is of interest to you. You can set this either here or with the Helm set command. Now let's give it a try. We can just take the command and apply it to our cluster. The only change I would make is I would set the additional argument to create the namespace, since I didn't do it upfront. And that's all. Once we execute that, the GPU operator is going to now create a new namespace. We can take a look and see that actually the GPU operator is already running. It has a couple of containers created, and we are going to have to wait for a moment, but once the operator is running, we can see that it is going to check the state of the cluster, and it is going to look for GPU enabled nodes, and once it finds a node with GPU, it is going to execute the init containers and install the drivers with the NVIDIA driver container that Garden Linux has prepared in this case. We'll have to wait for a moment. After the GPU operator installation has been completed and all containers have successfully started, the cluster is ready to use its GPU. Let's take a moment and test this. We can go and take advantage of the standard container provided in the NVIDIA device plugin for Kubernetes, which contains a device plugin for Kubernetes in a daemon set so that you can automatically expose the number of GPUs on each node, keep track of the health of your GPUs, and run GPU-enabled containers in your cluster. We can take advantage of the existing example here. So let's go to the run GPU jobs and just copy the command provided for us. This is going to create a pod which is going to run the standard NVIDIA container with a CUDA sample. Let's copy this in and we should receive an output similar to this one. Okay, let me just go to the default namespace and execute the command. Now we are getting a new pod, and inside this pod we expect to see logs very similar to the logs that we saw in the documentation. Wonderful, the test has passed and everything worked as expected. With this, I would like to thank you for your time, wish you happy usage of your GPUs, and please don't hesitate to reach out to us in case you have questions.